Welcome to an introduction to angles. A portion of a line that starts at a point A and continues through B is called a ray. Ray AB can be written using this notation. An angle consists of two rays with a common endpoint. The two rays are called the sides of the angle, and the common endpoint is called the vertex. So here we have the vertex, here we have one side, here we have another side. There are a couple ways to identify angles. If we call this point A, B, and C, if there's only one angle at vertex B, we can simply just call this angle B. However, we can also call this angle ABC, and the important part is that the vertex is the variable in the middle. Now, it is true that an angle can also be formed by two segments with a common endpoint. Each angle has a measure generated by the rotation about the vertex. The measure is determined by the rotation of the terminal side about the initial side. So here's our initial side, and the second ray, or the terminal side, has been rotated to this position. And when the rotation is counterclockwise, it's a positive angle. If the rotation is clockwise, it's a negative angle. The units used to measure an angle are either degrees or radians. We will start by discussing degrees. For degree measure, we assign 360 degrees to a complete rotation of the ray. You can think of this as the second ray going all the way around the circle. Therefore, 1/360th of a complete rotation gives an angle of 1 degree. Angles can be classified based upon their measure. The Greek letter theta is often used to name each angle. So let's take a look at the different types of angles. If an angle measures between 0 and 90 degrees, as we see here, it's called an acute angle. An angle that equals exactly 90 degrees is a right angle, and then any angle between 90 and 180 is called an obtuse angle, until we reach an angle of exactly 180 degrees, which is a straight angle. Then any angle between 180 degrees and 360 degrees is called a reflex angle. And then once we reach 360 degrees, it's called a full angle. Welcome to a presentation on angles in standard position. An angle is in standard position if its vertex is at the origin and the initial side is on the positive x-axis. So here we have two angles in standard position because the vertex is at the origin and the initial side of the angle is along the positive x-axis. An angle in standard position is said to lie in the quadrant in which its terminal side lies. So if we thought of this angle as the rotation from this initial side to this terminal side, it would lie in the first quadrant. Now we should also note there's an infinite number of angles that would also have this as its terminal side. For example, if we started here at the initial side and rotated it clockwise, this would be a negative angle, which would also lie in the first quadrant. And the same thing with the second angle. If we consider the angle where it's rotated from this initial side to this terminal side, this angle would lie in the second quadrant. But again, so would this negative angle here. So in general, angles between 0 and 90 degrees lie in the first quadrant, between 90 and 180, second quadrant, between 180 and 270, the third quadrant, and between 270 and 360 in the fourth quadrant. Now, if the terminal side of an angle happens to lie on one of the axes, it's called a quadrantal angle. So angles like 90, 180, 270, and so on would be quadrantal angles. Remember, if an angle is in standard position, the initial side of the angle is on the positive x-axis. And as we rotate the terminal side of the angle counterclockwise, one revolution would represent 360 degrees. If we rotate clockwise, we would have negative angles. So let's rotate counterclockwise slowly, and what we'll notice, say for example 4 degrees, is 1/90th of one complete revolution, or one hole.
We also see the conversion into radians, pi over 45 radians. And as we slowly increase the angle, again, you can see the fraction of the whole revolution that it represents, as we also see the measure in degrees. Once we reach 90 degrees, or a right angle, we can see that's 1/4 of a whole revolution, or pi over 2 radians. This is also called a quadrantal angle because the terminal side of the angle lies on one of the axes. And as we rotate now, we're looking at obtuse angles. Here we have a straight angle, another quadrantal angle. Is 1/2 of a revolution, or 180 degrees, or pi radians. As we continue, now we have reflex angles. And then we reach 270 degrees, which is another quadrantal angle, or 3/4 of a revolution. And then we finally reach a full angle, or one complete revolution. Again, if we were to do the same thing but go clockwise this time, we would represent negative angles. So there's negative 90 degrees, which is negative 1/4 of a revolution. Again, negative because we're going clockwise. And so on. This is very similar to what we just saw, except now the angles have a negative measure, negative degrees and negative radians. Now notice that we are looking at the unit circle because r is equal to 1, but r does not have to be 1. It could be any circle, so if we increase the radius, it will change where the terminal side intersects the circle, but of course it's not going to affect the angle. So we've seen a lot of different angles in center position. I hope you found this animation helpful.
Welcome to a lesson on radian measure. The goals of this video are to define radian measure, convert angles from degrees to radians, and from radians to degrees, and also to determine trigonometric function values given in radians. Just as it sounds, a radian is based on the radius of a circle. 1 radian is the angle created by bending the radius length around the arc of a circle. As we see here, the radius in red is the same length as this red arc, and therefore this is an angle of measure 1 radian. So because a radian is based on the actual part of the circle, rather than an arbitrary division, it is a much more natural unit. Now remember that the circumference of a circle is 2 pi radians, so it follows that 2 pi radians is equal to 360 degrees. So if we took this equation and divided both sides by 360 degrees, we could show that pi radians over 180 degrees is equal to 1. If we divided both sides by 2 pi radians, we could show that 180 degrees divided by pi radians is equal to 1 as well. And these are the conversions that we will use to convert radians to degrees and vice versa in just a couple minutes. However, let's first take a look at a Wolfram demonstration. What we see here is a 30-degree angle in standard position, and if we divide 30 degrees by 360 degrees, we would see that that is 1/12 of the whole circle, or 1/12 of a full revolution. So therefore, if we wanted to convert 30 degrees to radians, we could multiply 1/12 by 2 pi radians to get pi over 6 radians. So in this animation, as we change the angle, at the same time we see the conversion to radians. We'll stop here at 90 degrees, and we can see that 90 degrees is 1/4 of a revolution. Therefore, 1/4 times 2 pi would give us pi over 2 radians. And you can see this also marks off the number of radians on the outside. Again, this just shows a relationship between angles and radians. And again, we see 360 degrees is equal to 2 pi radians. And a similar relationship occurs when we have negative angles. Let's go ahead and convert some angles in degrees to radians. And what we do is we're going to multiply the degree measure by pi over 180 degrees and then simplify. Well, of course, some of these we should already know, meaning by definition, 360 degrees is equal to 2 pi radians. And of course, 180 degrees is half of 360 degrees, so half of 2 pi would be pi radians. Let's go ahead and show this one by hand. It's helpful to put 90 degrees over 1 and then multiply by pi over 180 degrees. And we need to simplify this. This simplifies nicely. This simplifies to 1, this simplifies to 2. Notice the units of degrees simplify out, and we're left with pi over 2 radians. Similarly, 45 degrees is half of 90 degrees, so half of pi over 2 would be pi over 4 radians. And I'll go ahead and show this one as well. 30 degrees over 1 times pi over 180 degrees. Simplifying. 30 degrees is equal to pi over 6 radians. And that's important because a lot of the angles that we will encounter will be multiples of 30 degrees and therefore multiples of pi over 6. And 60 degrees is 2 times 30 degrees, so we could just take pi over 6 and multiply by 2, or double it, and get 2 pi over 6, which is pi over 3 radians. But if we're ever not sure of the conversion, we can always just multiply by pi over 180 degrees. Let's do the opposite now. We'll convert from radians to degrees. And notice often when an angle is given in radians, the units are not given. It's assumed they're radians. Again, 2 pi radians is equal to 360 degrees. That's a given. Half of 2 pi is pi, so half of 360 would be 180 degrees. And let's go ahead and show this one. We want to convert pi over 2 radians to degrees, so we'll multiply by, this time, 180 degrees divided by pi, and simplify. Pi simplify out. This simplifies to 90 degrees. And again, the relationship here, pi over 4 is half of pi over 2, so half of 9 degrees would be 45 degrees. And again, this is important because if we have an angle that's a multiple of 45 degrees, we will have an angle that is just a multiple of pi over 4 radians. Pi over 6 times 180 degrees over pi. Again, the pi simplify out. There are 30 6's in 180, so this would be 30 degrees. And pi over 12, pi's are out. 180 is the same as 12 times 15, so this would change to a 1, this changes to a 15, and we have 15 degrees. So when you're first learning to work with radians, one thing that can be very helpful is to remember 2 key angles in radian measure. And the first one is 30 degrees is equal to pi over 6. The reason that's important is because if we have an angle that's a multiple of 30 degrees, it's going to be a multiple of pi over 6. So 60 degrees is 2 times 30 degrees, so it would be 2 times pi over 6, or 2 pi over 6, which simplifies to pi over 3. 90 degrees is 3 times 30 degrees, so it would be 3 times pi over 6, or 3 pi over 6, which simplifies to pi over 2. 120 degrees is 4 times 30 degrees, or 4 times pi over 6, which simplifies to 2 pi over 3, and so on. So this is actually a very helpful diagram when you're first learning how to work with radians. The second key angle would be 45 degrees being equal to pi over 4 radians. So if we have an angle that's a multiple of 45 degrees, it will be a multiple of pi over 4 radians. So since 90 degrees is 2 times 45 degrees, it would be 2 times pi over 4, which simplifies to pi over 2, and so on. So these 2 diagrams might be very helpful for some notes. Okay, I hope you found this video helpful. Thank you for watching.